Let's look at the question. Determine if a string have all unique characters. We are given a string, and we have to implement an algorithm to determine if a string has all unique characters. In the first approach, let's try to use brute force technique. We try to run two loops with variable I and j, and then we compare the string at I and string at j. If they become equal at any point, we directly return false. First, let's try to build a form which have column and row, which represent the string a, b, c, d, e, f, g, h. And then let's try to build the oppositor and ordinate represented by I pointer and j pointer. So I iterate from the first element, which is index 0, to the last element, which is index length of the string, -1. And we also have j. And we should eliminate the case when I is equal to j, because every character must equal to with itself, right? So we just move the j pointer from I plus 1 to length of string -1 in the first case, and in the second case, the j is moved from I plus 2 to length of string -1 and blah 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 until we finished. Because all of the string at I is equal to string at j, we should return true to indicate that all of the characters are unique, and it is the worst case because we have to iterate all of the elements. So it takes n-1 multiplied by n-1 divided by 2 operation, which is asymptotically equal to O of n squared time. So let's say we change the character f into character d. So in this case, we will have two character d in this string. So the program will terminate when we first time meet the duplicate d. We iterate I and j until string at I is not equal to string at j. At that time, we'll have to return false and terminate the program. So this is average case because we stop at the halfway. And if we change the character b into a, then it will stop in the first iteration because we meet the repetitive a, and it will stop. So it is the best case. It only costs O of 1 time. So first, we define a function union characters, which will input string, and it will return true if all the characters in the input string are unique, and otherwise we return false. So first, we're iterating over the string with two nested loops, and for each pair of characters in the string, we check if the characters are equal, and if so, we just immediately return false. And if it makes through entire loop without finding any duplicate characters, then we return true. Let's analyze time complexity. We let n be the length of the input string, and for each character in the string, we check all of the remaining characters for the duplicates. So it has to perform n checks for the first character, it has to perform n-1 checks for the second character, and so on. So which will result in n plus n-1 plus n-2 plus blah 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 plus 1 operations, which is equal to n multiplied by n plus 1 divided by 2, which is asymptotically equal to O of n squared time. The space complexity is O of 1 because we use a constant amount of additional memory regardless of the size of the input string, and the memory usage is determined by the variables I, j, and string, which all of them are fixed size and do not grow with the size of the input string. In the second approach, let's try to sorting them first. We use a sorting based on ASCII value of a character. We first define a function, unique characters, a string, and then if all the characters in the input string are unique, at that time we return true, and otherwise we return false. So first, we sort in the string, and then we check if any adjacent characters in the sorted string are equal. If we find any equal characters, then we immediately return false, and if it makes through the entire loop without finding any duplicate characters, at that time we return true. We let n be the length of the input string, and because we're checking the sorted string for duplicate, it takes O of n time, and sorting this string, it takes O of n multiplied by log of n time. So the overall time complexity is the sum of these two operations, which is also O of n multiplied by log of n time. The auxiliary space complexity is O of 1 because we only use a constant amount of additional memory regardless of the size of the input string. So the auxiliary space complexity refers to the additional memory used by this algorithm excluding from the memory used by the input, because the only additional memory used is only for a few variables like I, or some temporary variables used in the sorting process. So the memory used by the sorting string and creating some new string in the memory, it takes all of one space, but it is not counted toward the auxiliary space complexity because it is part of the input. In the third approach, let's try to use extra data structure. So this approach, let's assume we use a ASCII character set which have 8 bits. So the idea is to maintain a Boolean array for the characters. So there are 256 indices which represent 256 characters, and all the array's elements are initially set to false. As we iterate over the string, we set them to true at the index which is equal to the integer value of that characters. And if at any time we encounter that the array's value is already true, that means the character with that integer value is repeated. We let n be the length of the input string, and this function uses a for loop to iterate through each character in the string, and for each character we perform the constant time operation. We just computing the ASCII value by using the ordinal function, and then we updating the corresponding element in the characters array. So the time complexity is linear with respect to the length of the input string, which is O of n time. The auxiliary space complexity is O of 1 because the size of the character array is fixed at 256 and does not depend on the size of the input string. So the space used is constant regardless the size of the input string. In the fourth approach, let's try to use counter in Python. So this function will check if a given string S has all unique characters or not. Well, first, we create a list of characters in the string S, and then we use the counter method to count the frequencies of each characters in the list. So the result of the counter method is a dictionary. Well, the keys are the characters and the values are the frequencies. Next, the values of dictionary are extracted and converted to a list, and the filter method is then used to return only those values that are greater than 1, meaning those characters that are repeated in the string. And finally, the any method is used to check if any of the values in the filter list are greater than 1. And if no value are greater than 1, it means that all characters in the string are unique, and we use a node operation to return true, and otherwise it will return false in this function. We let n be the length of the string S, so the list function takes O of n time to convert the string S into a list of characters. We create a new list by iterating over an iterable object string and adding each item to the new list. So the time complexity of this operation is proportional to the number of items in the iterable string. So it takes O of n times. So the list of function also takes O of n space. The count method takes O of n time. Well, n is the length of the list that were created in the previous step, and the count method is used to count the frequency of each characters in the list which created from the string S. We need to iterate over the items in the input iterable list of the characters and count the frequency of each of them. So this operation requires us examine each item in the input iterable at least once. So the time complexity is proportional to the number of items in the iterable, which makes it O of n time. Well, n is the number of the item in the input iterable, and the space complexity is O of n. The values method takes O of 1 time, as it only returns a view of values in the dictionary, not a new list, and it also only takes O of 1 space because it returns a view of values in the dictionary, not a new list. The list function takes O of n time because we use a dictionary created by counter, and we convert the dictionary into a list of values. So the two instances of the list function, both of them have the time complexity of O of n. Well, n is the number of the values in the dictionary. So the space complexity is also O of n space. The filter method is used to filter a list of values which created from the counter method, and it takes O of n time. So n is the number of values in the dictionary which you need to iterate over the items in the input iterable list of values, and then we evaluate the function by passed as a first argument for each of the items. If the function returns true for an item, that item is included in the output iterable, so this operation requires us to examine each item in the input iterable at least once, so its time complexity is proportional to the number of items in the iterable, which make it O of n time. The filter method takes O of n space because we create a new list as our output iterable, which contains the items from the input iterable, and for each load function, it passed as the first argument, which will return true. So the size of the output list is proportional to the number of the items in the input iterable. So the space complexity of this filter method is also O of n space. The any method is used to check if any of the items in the output iterable from the filter method are greater than 1. So the time complexity of this operation is O of n. Well, n is the number of the values in the output iterable which from the filter method, because it needs to iterate over the items in the input iterable, and we evaluate the trustiness of each item until we find an item that is trusty or it has exhausted all of the items. And if we find a trusty item, we immediately return true. And if we exhausted all of the items and none of them are trusty, then we just return false. So the time complexity of this operation is proportional to the number of items in the iterable, so it takes O of n time. Well, n is the number of the items in the input iterable. The any method is used to check if any of the items in the output iterable from the filter method are greater than 1. So the space complexity of this operation is just O of 1, because we only need to keep track of one Boolean value. Because it does not create a new data structure to store its result. Instead, it evaluates the trustiness of each item in the input iterable one by one, and immediately return true as soon as it finds the trusty item. And if we exhaust all of the items and none of them are trusty, then we just return false, because at any given time, the any method only needs to keep track of a very little small amount of information, such as that the current item is being evaluated, and a flag indicating whether a trusty item has been found, which makes the space complexity is only O of 1, which is a constant space. So therefore, the overall time complexity of this function is O of n, and the space complexity of this function is O of n too.